So the star cycle, how the stars evolve in the space. So the star cycle, it always start with a interstellar cloud. We just discussed now. What is an interstellar cloud? The interstellar cloud is actually the combination of the dust and the gases. This is called an interstellar cloud. And as a result, what will happen of this interstellar cloud, as we also call a nebula. So these particles come closer to each other. As these particles come closer to each other, it start to form like cluster clumps together. As a result, the gravitation due to a gravitational force. So this will result in a formation. The particles come closer, and this started the first stage of a star. So we don't say a first stage. We don't say a first stage in a cycle. We don't say that it is nebula. Nebula is there. It's the birthplace of a star, the place where the star will form. And what is a likely place? If you see our solar system, if you see our Milky Way galaxy, this is a star forming region. These are the star forming regions are there. Because most of the matter, like the likely to formation of a nebula, can happen or occur in this region. The place where you find more matter. So first, when we start, we have a nebula. So first we have a nebula which means a combination of dust and gases. Then we have a protostar. What is a protostar? Due to the gravitational force, the star, the particles come closer to each other, the temperatures start to increase, and the star will become hot, and the nuclear fusion also start to begin. It's just a start or a beginning. What we call that as a protostar. These are some images, the real images of some protostar. Why the colors are different? Like some you see blue color, some it's even a same idea is there. It's the same protostar, but different imaging. Different imaging means some are thermal images, some are like X-ray emission. We are observing the X-ray emission. So we have a protostar. After a protostar, we have a main sequence star. What is a main sequence star? A main sequence star means in a protostar, it start to fuse. So in a protostar, what will happen when the particles come closer, the temperature increases, the molecular size, the interstellar cloud, the particles come closer. So it start to fuse together. It start a fusion of a hydrogen. When a fusion of a hydrogen just start to begin, we call that as a protostar. So this is an interstellar cloud. It turned into a protostar. In a protostar, it move into a cycle of a main sequence. What is the main sequence? When the fusion started, it create two things. It create a radiation pressure, which is pushing everything outward, and there's a gravitational force which is pulling everything towards the center. So when the radiation pressure balances with the gravitational force, so what will happen? The star will not change the size, and what we call that star, we call that as a main sequence star. So this is how, and our sun is actually a main sequence star, that the radiation pressure due to a hydrogen fusion balances with the gravitational force. So it won't change the size. Then the next, what will happen for the low mass stars, once the hydrogen, because what is the present here, that the hydrogen is fusing, and the fusion of a hydrogen result in a formation of helium. So the fusion of a helium happen, but it does not instantly. What will happen when the amount of a hydrogen start to decrease? The radiation pressure first start to decrease. So as the amount of a hydrogen is getting less, the radiation pressure start to decrease. As the radiation pressure start to decrease, the size of the star will shrink. So when the size of the star will shrink, Like the size of a sun, first it will shrink, it will decrease. When the size of a sun will decrease, because of this decrease in size, the temperature of the sun will increase. Because as the temperature of the star start to increase as its size is decreasing, it start a fusion of the element which is helium. So now the helium fusion started because of decrease in size. So when the helium fusion started, the helium fusion released the radiation, and the radiation pressure of the helium fusion is more than the gravitational force. So as the size of the star now increases again, and it will be much bigger than the main sequence star, and what we call that as red giant. So red giant is actually a star which so sun is expected to be a red giant. Once the hydrogen will fusion will slow down, the sun size will first shrink. When the size of a sun will decrease, the temperature will increase, and that temperature is enough to start a fusion of helium. The fusion of the helium releases more energy as compared to hydrogen. So as a result, the gravity is weaker and the radiation pressure is greater. So the size of the star will increase. What we call that as supergiant. Or so as a result, it will form red giant. You can say red giant, or what is the difference between a red giant and a supergiant? The difference is their size. If the mass it is like 4 times the mass of the sun, it will form a red giant. But if it is more than the size of the sun, like 4 times, then it will form a supergiant. So the same concept will happen for a red giant or a supergiant. It's just the size of the interstellar cloud. If it was started with a low mass, then definitely it will form a red giant. But if it is high mass, it will form a supergiant. Is it clear, the concept of a red and a supergiant? Anyone having a doubt or a question till this point?
No, sir.
No, sir.
Okay. Now, what happened to the death of the star? How the star ends? So, for a low mass star, what will happen? It will form a planetary nebula and then a white dwarf. So what actually happened? See, if I draw the stages of the star, you will understand much better. Say this was an interstellar cloud. This was an interstellar cloud. The interstellar cloud, because of the gravity, pull everything towards the center. What it will form? It will form a protostar. A protostar is a star in which the hydrogen fusion just started. When the hydrogen fusion started, the protostar will reach a point where the fusion and the gravity have the same strength. Gravitational pressure and the radiation pressure have the same strength. What we call that as a main sequence star. So we can say this as a nebula. We can also say this as an interstellar cloud. It's the same thing. You can say interstellar cloud. You can say nebula is actually a place where stars likely to form. Interstellar cloud is a group of dust and the gas is called interstellar cloud. So when you have a nebula, definitely there will be interstellar cloud. So this is the interstellar cloud. This one is what? It's a protostar. This one is what? This is a main sequence star. Then once it turned from main sequence star, so once it reach a main sequence star, the gravitational force is known as gravitational pressure is same as the radiation pressure. Now what happened? As a hydrogen fusion decreases, the eases. So as a result, the star size first shrink. First it shrink. It does not increase, but because when it shrink in size, the helium fusion start, and the helium fusion start cause the star to increase in size, and what it will become? It will turn out to be a red giant. Now, from a red giant, what will happen? How the star end will happen or occur? Like example, here it was undergoing a helium fusion. Here it was a hydrogen fusion. Here the hydrogen fusion, but just started. Once the helium fusion decreases, like it run out of a helium, then what will happen? Again, the stars start to shrink. But this time, when the stars start to shrink, it reduces the size. It pulls the gravity. The gravitational force is there, which is pulling. So as a result, it is not able to start the fusion. The temperature of a star again increases, but this temperature increase in temperature is not able to start a fusion of the heavy element like carbon, nitrogen, oxygen, and so on. So as these elements are not able to fuse together, protostar. This is a protostar, main sequence star. Proto, Proto, main sequence, main, MAIN, red giant. As the temperature increases, but the heavy elements such as carbon, nitrogen, oxygen, they are not able to fuse together because the temperature is not sufficient. So as a result, what will happen? The core of the star, the center core of the star, more mass is there in the core, and remaining particle remain at the surrounding. What we call this, we call that as a planetary nebula. What is the difference between the interstellar? What is the difference between interstellar nebula and interstellar nebula? Is a place where this actually one nebula is there, the end cycle of the low mass star. One is the beginning of the star. The beginning of a star, when the stars start to form, yeah, it will be a white dwarf. But the thing is that how the white dwarf is formed, the center part, the core is actually turning into a white dwarf. And the surrounding is there, which is left behind, the remaining thing of the star. What we call this collectively, we call that as a interstellar cloud, or we also call planetary nebula. So there's a difference between interstellar nebula and the planetary nebula. Interstellar nebula is the beginning, but planetary nebula is the end. Is it clear? So the central core of the star, what is left in the central core, that will be a white dwarf. So if we see a cycle of the star, the low mass star, you can see here. First we have a protostar. Leave this T Tauri phase. Then it will turn into a sun-like star, which is a main sequence. Then it will turn into a red giant. Then it is a planetary nebula. What happened in a planetary nebula? Most of the things in the surrounding are left behind, and the core, which is very hot, that core will turn into a white dwarf. And a white dwarf will turn into a black dwarf. But this is a theoretical black dwarf because the time taken by a white dwarf to turn into a black dwarf is more than the age of universe. Like age of the universe is 13.9 billion years. But to convert from white dwarf to black dwarf, the time interval is much higher. So we don't see any black dwarf. It is just a hypothetical. It's just an assumption that it will turn into a black dwarf. Is it clear? The star cycle of the low mass star? Anyone having a
Yes,
doubt or a question?
sir.
Yes,
No,
sir.
sir.
No, sir.
Then what will happen if the star is a massive star? If the star is a massive star, then what will happen? It will explode. Like first, the same stages. It will be the same stages. First, when we started, it will start with a interstellar cloud. Then it will be a protostar. Then it will be a main sequence. And instead of a red giant, this time it will be a supergiant. And once it turned into a supergiant, when the supergiant, the helium fusion stopped, it started with a heavy element fusion, such as carbon, nitrogen, oxygen. So as a result, what will happen? The star will explode, and this explosion, what we call that as a supernova. So supernova, as you can see on the top right figure, this is called a supernova. It's an explosion of the star. The star exploded. Why does the star explode? Like why the low mass star was not able to explode, but the high mass is able to explode? Because when it reaches a red giant, say there was a low mass star. This is a low mass star, the cycle of the low mass star. And this is a cycle for the high mass star. So low mass star, it will be a main sequence, high mass also main sequence. Low mass will turn into a red giant, high mass will turn into red supergiant or supergiant, you can say. Then what will happen? The helium fusion, this was happening a helium fusion, here also helium fusion. Both helium fusion is happening. Okay. Then what will happen? This again, if the helium fusion decreases, the stars start to shrink. It start to pull everything towards the center. The gravity is stronger. As the gravity is stronger, everything is pulled towards the center. So the temperature of the star increases. But if this increase in temperature is not sufficient to start the fusion of the heavy elements such as carbon, nitrogen, oxygen. These elements are not able to fuse. So if they are not able to fuse, they are left behind in the surrounding, and the center core is turning into a white dwarf. But what will happen if we have a high mass star? There was a hydrogen fusion, then there's a helium fusion. Once the helium fusion stop, again the star start to shrink. As it shrink, the temperature start to increase. As the temperature increase, as the temperature of the star start to increase, what will happen? It start to this increase in temperature is enough, like it is much higher as compared to low mass star. So start a fusion of the heavy elements such as carbon, nitrogen, oxygen. These heavy elements are there, they start to fuse together. When these heavy elements start to fuse together, the radiation pressure is so high, the outward radiation pressure is so high compared to the gravity. So as a result, what will happen? The star will explode. So as you can see here on the top right, the explosion of a star. Why the star exploded? Because the heavy elements start to fuse together and they are releasing greater amount of energy. As so that's not the gravity is not able to hold this structure, so the star exploded. And what is the evidence of a supernova? Because we have element like iron is there, the heavy elements are there. So existence of a supernova, the existence of a supernova is actually like the supernova occur, the presence of these elements such as iron is there, the heavy elements, it's an evidence of a supernova, because they can only be produced if the supernova happen or occur. If the star does not explode because of the fusion of the heavy elements, it will be impossible in our solar system even that we will get these heavy elements. So existence of these heavy elements is a proof that the supernova have already occurred. Then when a supernova happen or occur, then this may leads to two things. It might form a neutron star or it may form a black hole. The both possibilities are there. If the supernova happen, when the supernova occur, what is a neutron star? Actually, a neutron star is it is a massive star, the star with a very high mass. You can understand the concept of a neutron star like if you take a one tablespoon of a sun, it will weight about, like example, 2 tons. But if you take a one tablespoon of a neutron star, it will be the mass of the whole, like it will be about billions tons of the mass. If you take the mass of every person on the earth, that will be equals to the 1 tablespoon of a neutron star. Like if we take all the population of the earth and we measure the mass of every person and we sum that, the mass of a neutron star, 1 tablespoon example of a neutron star, will be even more than that. So the neutron star is The neutron star is so massive. That's just to imagine how massive the neutron star is. And it is so massive, it has a very strong gravity that it damaged the atom. Because in an atom, what is the structure of an atom? An atom contains neutron and protons and electrons. The neutron star is having a so intense gravity that it destroys the structure of an atom. How it is destroy the structure of an atom? The gravity pull everything so that the electron and proton are fused together. So electron and proton are almost fused together. So as a result, what will happen? We are only left with neutrons. So in a neutron, the force of a gravity is so strong that we are left with neutrons. That is called a neutron star. Neutron star is a very dense star and it spin at a very high rate. When it spin at a very high rate, it gives us electromagnetic radiation. We also call these neutron star as pulsars. The neutron star is another name is there. It is also known as pulsar. And the presence of the neutron star, what is it like? Pulsars are there, and lot of pulsars in our and even in our galaxy, lot of pulsars. So, or there's another possibility is there that it might turn into a black hole. What is a black hole? What is the meaning of the term black hole? Black hole means when the star explode, it almost emit out all, like it has so massive. Like if you compare a black hole and a neutron star, so say this is a neutron star, the same size black hole will be like this. So black hole and a neutron star, the main difference is the concentration of the mass. So it's not like black hole should be black. Why we say them as a black hole? Because it is so strong gravity that even it does not allow light to escape. So we don't see a light escape from the black hole. That's why it's not like it appear black, but it's not like it's black in color. The idea is that it is not allowing the light to escape, so it appear to be black. So we have the sequence of the stars. As you can see, the main sequence star, the protostar, it will turn into a low mass star, then into a red giant, planetary nebula, white dwarf, and a black dwarf. But if it's a high mass star, it will turn into a red giant, then a supernova, which may lead to a neutron star or pulsar or a black hole. So these are the two cycles of the stars which you have to learn. What would
Sir,
happen
if
if we come close to the neutron? If you come close to a neutron star, you will be shredded into a very small, even because a neutron star does not allow the atoms to be like it changes the atoms to neutron. How it changes the atom to neutron? Because we are also made up of atoms. So it's so strong gravity that it pull everything towards and break the structure. So you will be like reduced to a particle size. So what is a pulsar? Pulsar is another name which is given to a neutron star. How would we manage to see how it looks like? How we are able to see that how the black, you mean a neutron star or a black hole? The pulsar, actually what happened? The pulsar rotate at a very high speed, about 7,000, I guess 7,000 vibration in 1 second. So as a result, it produces a very intense beam, electromagnetic radiation. That is how we detect the neutron star. As you can see here, the image, this is the animation which shows a neutron star. So it's emit out electromagnetic radiation to a very high spin. Is it clear? Anyone having a doubt or a question till this point?
No, sir.
And one of the student, what is quasars? Actually, what it represent? It's just a
Now it is a high mass star or low mass star.
which one?
Will they tell us?
In exam? Sorry, I don't get it. What you ask? Anyone having a doubt or a question? The color of the star is depends on the amount of a nuclear fusion, the rate of a nuclear fusion. The star of the class, the stars, neutrons are large than the galaxy. No, 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 no. Neutron star is not larger than the galaxy. Neutron stars are not larger than the galaxy. This is how the neutron star is so dense gravity, so they're smaller. Yeah, I said the same thing. The neutron star is not large. The galaxy is a combination. This is a Milky Way galaxy. Even in a Milky Way galaxy, you have 10,000 pulsars, neutron stars. This is how our Milky Way galaxy look like. So even in a Milky Way galaxy, there are 10,000 pulsars. So it's the size of a neutron star is smaller than the Earth. Like size of a neutron star is like a size of one town, you can say. But the gravity is so strong. That is the idea. The gravitational force is so strong for a neutron star. So just a quick revision, what we have discussed about the stellar evolution, that we have two ways the star can evolve. The temperature of the star decided the color. Like some stars, one of the student asked, like some stars appearing to be blue because of the temperature. As there's one table, it's not memorizing, it's just the idea that if the temperature of a star is very high, what it will appear? It will appear blue. And if a temperature star is very low, it will appear red or yellow orange. So our sun is not a very hot. If you compare the stars, there are some stars which are much hotter, not some, many stars which are much hotter than the sun. But this is additional information that's not related to exam. Exam point of view, you have to learn this. So a quick revision, what we have discussed. A quick revision, what we have discussed, that we have a main sequence, we have an interstellar cloud, or we have dust, you can also say, that come closer because of a gravity start a fusion. A fusion is started, a fusion balances with the radiation. Fusion balances with the radiation, so it releases energy, and the radiation pressure balances with the gravity. It's a main sequence. If it's a low mass star, if a hydrogen fusion finish, it start a helium fusion, so size will increase, it will turn into a red giant. A red giant, when it uses helium fusion, it again start to collapse, but the no more fusion happen or occur. So it left behind a very dense core at the center and the remaining particles around we call planetary nebula. And in the center core of a planetary nebula, it will be a white dwarf. And theoretically, a white dwarf, it's a very hot, it will turn into a black dwarf. But then we can have a if a planetary nebula, sorry, if it's a gas, giant gas cloud is there, which is massive, it will start a protostar and then it will form a main sequence star. It start a like protostar, there is a fusion, but that is not equal to gravity. When the fusion rate is equals to the gravitational pressure, the star will not change the size. We call main sequence star. And then when helium fusion start, the size increases because the gravitational force is less than the radiation pressure. We call a supergiant. Then a helium fusion stopped and fusion of the heavy element started. Then there's explosion, the star exploded, and we call that as a supernova. The supernova release enough amount of energy which will outshine the whole galaxy. Like if any galaxy right now supernova is happening, then that energy which is emitted out from this supernova will outshine the whole galaxy. Like it will emit more energy as compared to the whole galaxy. And that's why supernova can also be used to estimate the distance between us and that galaxy. So as different galaxies, different stars are going on different cycles. So any star which undergo a supernova stage, we can focus on that star and we can determine the distance of that galaxy from us. And then a supernova release energy, like most of the if it all matter confined and the gravity is so strong, it will destroy the structure of an atom. We call a neutron star. But if it become very massive, that it does not even allow the light to escape, what we call that as a black hole.